Okay, what are we doing? We are talking about this abacus. This is an abacus, and this abacus helps me count. And so what we're going to do is we're going to go through this workbook. This workbook is talking about abacus and preschool, and I'm trying to make it look like it's fun. But you know what it is it's abacus. So what we're doing is we're learning how to do math. What are we doing? We're learning how to do math. How do you work this thing? This thing is what we're going to do. So the first thing we're going to do is understand this is an abacus. This is the beads. All of these beads are numbered, right? So when we look, we have the bottom beads and we have the top beads. Because we have the bottom beads and we have the top beads, we can count that that is 1. After 1, that is 2. We have 3 and then 4. After 4, we have 5. That's what we're doing. We're talking about the abacus. So then when we look, we have 6. That is a value of 6. How do I know? Because I have 5, 6, and then 7, and then 8, and then 9. That's what it is. That was what an abacus does. And so what we're doing is we're learning how to read the abacus. When we learn how to read the abacus, we will go further into adding, subtracting, multiplication, and division. I don't know if we're going to get into division. But anyways, what we're going to do is we're going to be talking about this abacus. So if you notice, this is 0. 0 just means that none of the beads are touching this horizontal bar. This horizontal bar is what counts the, so then that means there's nothing here. What we're going to do is we're going to trace, all right? And if we're kids, we're going to trace, and we're going to trace the number 0. That's what the number 0 looks like. Okay, we know what that is. All right, let's move on. Okay, here is the number 1. Because it's a number 1, notice that there's 1 pig. So if we have 1 pig, we're going to do 1 bead. So if we can relate, this 1 is equal to this. So it's a 1-to-1 right now. Right now it's 1-to-1. But it gets better as we go further. So we have 2 snakes, 1, 2. When we look, 1, 2, 1, 2. And it kind of relates to each other. We have 3. Why are we doing this? We're just learning how to read the abacus. Hello, Carlos. What are we learning? We're learning how to read the abacus. What is an abacus? An abacus is a counting tool. I hope you're here to learn. Please. I'm hoping that you can...
Now, open your mind to me, please. Open your mind.
Thank you, Carlos, for making the comment, because I do appreciate everybody making comments and wanting to learn how to read the abacus. The abacus is a counting tool. It is a math manipulative. So when we look, we have 3 chipmunks, and I'll do 3, 1, 2, 3. 3 on the abacus. When we looked at this is 3 on the abacus, the horizontal bar is what tracks the number, right? It tracks the beads. So anytime the beads are touching this horizontal bar, this is what's being counted. So if I did this, these are all 3s. Every column that we see here is a value of 3. And then what do we have is we have 4. What we're doing is we're just learning how to read the abacus. So this is 4. All of these beads that are touching this is 4. And then when we look, we have more activities about bead recognition, number recognition. This is a 1-to-1. RT, welcome back for life. Welcome, welcome, welcome. I'm so happy you're here. Yeah, today I was a little late, but I'm here. So let's see how far we can go. That's 21. I don't know what's 21. This is 4. 21 looks like this. 21. That's what 21 looks like. But thank you for asking. But this one is 4. 1, 2, 3, 4. We know what 4 is. So when we look, this is what 4 is. 1, 2, 3, 4. These 4 beads are touching the horizontal bar. What? What, Carlos? I love this. Oh, thank you so much, Blaze. So what we're going to do is we're going to be matching. When we match, right, we're just like matching. Matching numbers. Okay, I don't need to show this. What are we doing? We got to go to 5. I'm showing what the number 5 looks like. Carlos! I don't know what your name is so funny. It's like every time I look at your name, I'm yelling at you. Carlos! So, what's wrong? What's wrong, honey? What's wrong? So what are the 2 columns to the right of the decimal? Actually, this is not a decimal. This is, can you do... Yes, we will. We will. Let me finish counting up to 9, and then we will do it. This is not a decimal. This is a indicator. This is like a label. This is my ones label. And with the ones label, you're right. These are what we call decimals. So when we look, we want to choose.
I choose you.
We want to choose this dot. So if you notice, there's one dot here and there's one dot here. But if I did this dot, then the ones would be over here, right? So if I did that one,
okay, Charizard, I choose you.
It'd be here. So if you notice, on my ones, my tens, there's no hundreds, and then there's no thousands. So when we look, I'm usually here. I'm usually over here when we do the ones, the tens, the hundreds, the thousands, the 10,000. Does that make sense? R and T. So when we're looking, let me just finish this, and then we will go into asking questions. Yes, hold on, Carlos. Let's put a pin in that. So let's finally look at number 6. And then we're done. No, we're not. We still have to go to 9. Why? Because this is 5, this is 6. 1, 2, 3, 4, 5, 6. There's 6 sheep. So 1.02, yes, exactly. So the number 105 would be it. This is what 3rd graders are learning? No. No. This is not what 3rd graders are learning. But it can. And then what's 7? After 7, right? So when we look, 1, 2, 3, 4, 5, 6, 7, 7 crocodiles. So when we look, we have 7 on the abacus. That's what 7 is. 5, 6, 7. And then we have 8. 8 bunnies. 8 bunnies. 5, 6, 7, 8. And then our final number is 9. We have 9 cows. Like that. That's what 9 cows look like. So we have 9. 5, 6, 7, 8, 9. If that makes sense. All right, so let's continue on and start looking at our place values. When we look at our place values, you'll notice that every column can be 9. So this is 9, 9, 9, 9, 9, 9, 9. So these are all 9s. And if you look, I have this. So this is what we are looking at our place values. 9, 9, 9, 9, 9, and 9.99. So that's what R&T was talking about. Carlos asks, what grade is this for? I'm trying to gear towards young children, like preschool, because if you notice, I'm not sure if you read that, but that's what this is. This is my preschool abacus book. So it'd be kids that are as young as 3. So I teach as young as 3, and as long as the kids have a good attitude, I can teach any age. But they have to have a good attitude, right? They have to make sure that they...
Now open your mind to me, please. Open your mind.
Thank you, Ethan. Yes, every age can learn this. And so I'm teaching you guys right now. And why am I teaching you? Because I think it's the greatest thing next to sleep bread. Preschool. Man, y'all gotta give them kids a break. This is too hard. Total Recall. Right, Charles? Good. Total Recall with Arnold Schwarzenegger. So when we're looking, right, we want to do is we understand, like, there's a one-to-one. So that's how we're doing. So let's review a little bit again. So here is my book that I have. And this book tells us how to read the abacus. And so if we're looking, this would be 1. So on our abacus, we have 1, 2, 3, 4. This is 4. Now we have to do the value of 5. So this is 5. And then 6, 7, 8, 9. If you notice, this is 1, and then if I add the 5, now we have 6. If I have 2, and I add the 5, now I have 7. When I have 3, 1, 2, 3, and I add the 5, now I have 8. And then I have 4, 1, 2, 3, 4, I add the 5, now we have 9. Okay, I'm following. Okay, good. Thank you, R&T. 6, 7, 6, 7, 6, 7, Carlos. That's what 67 looks like. If you want to look at 6, that's what 6. And then that's 7. So when we're looking at 6, 7, that's what it would be. 6, 7. What is the importance of this? So we can visually see our numbers. That's the importance. If you're interested in those kids doing this, they're doing this. They're doing this abacus in their brain. You could do it too. Usually, we start them young. We start them young. All right, the first thing we're going to do is we're going to do this R&T. Are you ready for some mazes? What we're going to do is we're going to look at some mazes to see if we can recognize the beats. And so this is a maze that I created, and this is available in the shop. That's where we go. There we go. There we go. So if you notice, this one is a 2-digit. Right now we're doing 2 digits, and it gives you a little example like how to read the abacus and exactly what I just went through. So we talked about the 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every column has a digit, and then if you notice, we're going to be talking about the ones and the tens. When we look at is the is the mental abacus muscle memory too? I believe it is because you see the kids do this. And so they're trying to, just like writing, hello Neon, welcome. Just like when we're writing, right? It's kind of muscle memory when we write in the air. So it's kind of like that. I can see that, if that makes sense. So it's kind of like writing, like kind of, when we do that. I've always wondered how to use the abacus. Oh, hey, Ella. What we're going to do is we're going to read the abacus. So let's see if we can do it all together. So here is, thank you, R&T. Here's my number. Again, we're only going to do 2 digits. So if I have my tens and I do this number, and I have my ones and I do this number, what number do we think this is? Thank you, Neon. You're so quick. Thank you, Ella. Yes, makes sense. So we have our 1 and 4. 1 is my tens and 4. 1, 2, 3, 4. So when I look, I'm going to go down. So I follow this path and I go down to this one. As I go down to this one, my next number is this. So I have this number. If I have my 0, right, there's no beads touching my tens, and I have this number, what number do we think that is? Thank you, Crush Star. It is 14. Yes. Neon, yes, 2. It's a 2. No, Carlos, 20 would look like here. This is a 2 and this is a 0. Just as how you wrote, right? What you did was a 2 and a 0. I'm not sure why it would be not 2. So 2, 1T would look like 2 and a 0. What we showed was this, 2, because it would be a 0 and a 2. So 2 goes up to here, and we're now here. When we look, I have my tens and I have my ones. So I have my 5, 6, 7, and then 5, 6, 7, 8. What number is this? 78. Yes. Thank you. Thank you, Neon. This is too easy for you. R&T, yes, thank you. R&T for life. Yes, good. 78, 78. Great. So we're going to continue on with 78. We're going to move over here, and my number is here. So if I have my, can we see that? So if I have my tens, I have my tens, and then I have my ones. I have, what number do I have? What number do I have? Almost. It is almost 44. Yeah. See, 44, quiet for you, would be 44. So every column has 9. So when we look, Charles, we have 4. 1, 2, 3, 4. 1, 2, 3, 4. We have 44. And then if I do 5, this is what 5 looks like. Yes, thank you, R&T. It is 22. Thank you, Neon. Yes, Ella. Neon trying to be the Tetris pet. Neon has been around for a while. Don't be hating on Neon, because Neon's been around for a little bit. Like, we've done multiplication on the abacus. And did we do division as well, Neon? Okay, so that is 22. Yeah, we did do division. Oh, that's right. You keep doing it. Yes, we did. Okay, so we have this number. We have our tens and our ones. So my tens, if I did this, what number would this be? Oh, yeah. Neon's been here, just like Ethan. Ethan's been out here for a very long time. Thank you. It is 10, because this is our tens, and then we have our ones. When we look, we have our tens, and we have our ones. So this would be 10, because it's a 1 and a 0. Thank you, Ella. Okay, so that is what we're doing. When we look, this is not mirrored. I'm not sure where it's going wrong, but this is not mirrored. You're looking at it correctly. So if I have my tens and my ones, I have this number with this number. Charles, are you okay? Does this make sense? So what we're doing is we're doing we're reading the abacus. Thank you, R&T and Neon, because we have 30, 1, 2, 3, and then 3, 1, 2, 3. Excuse me. So 33 goes down to here, and then we have this number. Oh, we have number. Okay, so this is our tens. So if I would do this like that, right? This is our tens, this is our ones. So we go tens, right? And then we go ones. So we have 96. Thank you. 90. 5, 6, 7, 8, 9. That's 90. And then we have 6. 5, 6. I think Neon has memorized the maze. All right. So again, what is this number? We have this number. Oh my goodness. Do you skip 8? No, we didn't skip 8. We didn't do 8. So we have 8. This is so we have 5, 6, 7, 8, and then we have 2. So it's 82. Thank you, Neon. Yes. Does that make sense, everybody? You don't lost the past two. Neon looking at the picture and not the abacus. Yeah. Yeah. You can look at the picture because that's what it's for. Ha. Right? Then we have this number. When we look, we have our digits. The abacus is just here to help you guys, right? To read the picture. No, but I will rewatch. Okay, 76. Good, 76. Does that make sense, everybody? 76. So when we're looking, the top value will always be 5, right? So if the top value is always 5, this would be 5, 6, 7. And then we have 6. How do I know? Because we have 5, 6. So we're going to review with Charles. We're going to count 1, 2, 3, 4. Charles, does that make sense that this is 4? Okay, let's see. Okay, Charles, did that make sense that this is 4? So, because I know sometimes I talk a little fast. So when we're looking that this is 4, 8. It is 8 because we have 5, 6, 7, 8. The abacus. This is my question. Do you see that this is 4? Your user number has the number 4 in it. Okay. I don't know. Okay, that's 8. We go up to here. Hey, Foxy. Hey, Foxy. Oh, sorry. Yes. We have 60, 6, 5, 6, and then 9. 5, 6, 7, 8, 9. And my final answer, what number is that? If I look at that and then do that, what number is that? Yes, thank you. Okay, that's it. That is the end of the maze. So how did that work for you? Okay, so that's the maze. And what we're doing is we were looking at making sure we understand how to read the abacus. When we read the abacus, then we can go into learning how to add, subtract, multiply, and divide. But this is the actual maze. Oh, and then I have a reverse maze. So that means, let's see. Okay. So you'll see that there's a path, and I give you the number. I give you the path. But you're supposed to be here. You're supposed to color in the amount of beads. 5, 1, 2, 3, 4. And then you come to here, and then you'll notice that I have 96. So 96 goes to here. And we're going to put 90. 5, 6, 7, 8, 9, and then 6. 5, 6. So that's how we do the, maybe that's what I should do. So this one goes up to here. So we have 1, 2, and then 9. 5, 6, 7, 8, 9. So that was my thing. I have to come back. You're starting to lag on my end. Sorry. We'll take it slow. Okay. Okay. So this is the maze for the abacus. If you're looking for more mazes on the abacus. Okay. So we're done with that. Excuse me. Gosh. So now we're going back to here. Ella. Oh, great. But there's more. But wait, there's more. Excuse me. Allergies are really sucking right now. Thank you for the coral, Ella. Ella? Okay. We're going to start learning how to move the abacus. Now, if you notice, the abacus is made out of plastic. This is out of plastic. And it doesn't matter what the numbers are. So what we're doing is we're understanding how to move the beads. When we look at the abacus, right, what I'm going to do is I'm just going to use the edges of the beads to move the abacus. When I move the edges of the abacus, right, notice it's very easy to move. It's very simple and easy to move. Excuse me. But what does that mean? You don't want to be aggressive when you're working with the abacus, right? You don't want to be aggressive. You want to be able to just easily, gently move the beads, because that's what we're doing, being gentle. So if I have a number, right, 55555, and I decided to do that, you'll notice that my answer now becomes wrong, because...
And flick. Oh, you flicked too hard, damn it!
Because you flick too hard. So don't flick too hard, because you're going to mess up your answer. So when you do it, make sure you only be intentional, but move it gently. So when I'm doing it, right, I'm just moving the beads just like that. So what are we going to do is we're going to start adding the 1. What are we doing? Why? Why are we adding the 1? Because I want to show you the basics of adding on the abacus. What does that mean? Well, if I have 5 on the abacus, right, my question will always be focused on the add-in. Can I add 1? Can I do it?
Yes, we can.
Yes, we can. So we just add the 1. That's all we're doing. We're moving to the horizontal bar. Now we're adding to the 1. So what are we doing? We're doing preschool abacus math in this book. And towards the end of the book, we're starting to do some adding and subtracting. We're showing the kids, we're showing you, I'm showing you how to move the beads, right? And so what we're doing is we're understanding that if I was to have 7, if I have 7 on the abacus and my question is to add the 1, notice I'm not focusing on the result. What I'm focusing on is the add-in. And so my question is can I add the 1?
Yes, we can.
yes, I can add the 1. That's all I'm doing. So I'm trying to show what we're trying to do. So again, when we look at 2, we don't look at the result. What we're doing is we're looking how to move the beads. So if my question starts with 5 and I want to add the 2, I'm going to add these 2 beads. That's all I'm doing. Is there enough to add the 2 beads? Yes, there is. So I'm just going to add them. And it's the same thing with the 3. So the reason why this is cut off is because this is an activity where they answer the question and then they have to find the answer to the puzzle part. Okay, so I have 3 when I add the 3. If I have 5, and my question is I'm going to add the 3. Is there enough to add the 3? Yes, there is. So I'm just going to add the 3. Notice all I got to do is just add the 3 because I have enough beads. So my final answer is 8. Now, how is this different than mainstream math? Well, mainstream math, we use numbers, right? We use actual numbers like these. But the problem is these numbers are very symbolic. So sometimes what do? They tell the kids, okay, what we need to do is we need to, I don't know, draw 5 dots. 1, 2, 3, 4, 5. And then you add 3 dots. 1, 2, 3. And then you got to count it all together. You could do that. You could do that. On the abacus, the way we do it, we just add the 5 and then we add the 3. That's all we're doing. And then we know, because we learned how to count, we learned what this number is, we know that this is 8. Anybody have any questions? So what we're doing is this one. All right. And I add the 3. Is there enough beads to add the 3? Yes, there is. So I'm just going to add the 3. I hope that makes sense. So again, what we're doing is... So 4 is kind of easy because there's only 2 questions with 4. It's 5, and then add the 4, or it's, and my answer is 9, or it's 0, and you add the 4. There's not too much with 4. So, but 4 is just an interesting number. So now we know how to add. When we subtract, what are we going to do? When we subtract, notice when I go to the horizontal bar, it's adding. When I go away from the horizontal bar, we're subtracting. So now we have 2. So if we go to the horizontal bar, this is 3. I go away from the horizontal bar, now we're subtracting. If we do minus 2, my final answer is 1. So again, what we're doing is we're focusing on the add-in. We don't need to worry, oh, this is not an add-in, this is a subtract head. I don't know why they use subtract head. Ugh. We have to worry about the subtracted. I don't know why we say it like that, but whatever. So this is 4. If I have the 4 and I want to take away the 2, if I take away the 2, it doesn't matter which 2 beads it take away, as long as I take away the 2 beads. So I move it away from the horizontal bar. Does that make sense? So what we're doing is we're add to the horizontal bar, we subtract to the horizontal bar. What are we doing? We are doing math. We're doing midnight math in the middle of the night. So we have 8, 8. This is 8. So I have 8 and I take away the 3. I take away the 3. My final answer is 5. Let me know if you have any more questions, but I'm just going to continue on and show you how to work the beads. So we have 4, we add 4, we take away 4, we take away the 4. And my final answer is 0. Alright, we've done the 4s. We're done. Well, we still got to do 5, right? 5 is this. If I have 0 and I add the 5, now we have the answer is 5. If I do this one, which is 3, and I add the 5, do I have enough? Yes, I do. So I'm going to add the 5. My final answer is 8. We know that this is 8. 5, 6, 7, 8. Yeah? 6. How do we do 6? 6. There we go. 6. It is available in the shop, or if you want to, it is available, if I can find it. It's also available here. Where is it? Where is here? I don't have it. Oh, there it is. It is available here as well. Hi, my name is Lynette. I've been teaching Abacus for about 20 plus years, and I have all these workbooks if you're looking for workbooks to introduce Abacus to your child. So, you can find my name here, and you can find it here, or you can find it in the Amazon, or the TikTok shop. Either or, doesn't matter. It's all the same. So here is 7. When I look at 7, I have 2, And then I want to add the 7. Oh, sorry, there's my 2. Can I add the 7? 7 is 1 on the bead on the top, right? This is 5, this is 6, this is 7. So when I bring it together, this is 9. 5, 6, 7, 8, 9. What we're doing is we're just reading the abacus and moving the beads. Anybody have any specific questions? We can continue on. We have 8, we have 1, right? We have 1 on the abacus. And then my question is, do we have 8? Is there enough to add the beads to 8? Yes, we can add 8. So my final answer is 9. And then 9 is not too many, right? 9 is either 9 minus 9, 9 minus 9. And then, again, we know if we need to add, we can subtract. So I have 7, and I add the 1, and then I take away the 5. When I take away the 5, right, I'm just moving away from the horizontal bar. Hey, Zorfi. Welcome back. We have 3, we have 5, we have 8, and then we take away the 5, right? We move it away from the horizontal bar. My final answer is 3. Yay! All right. And then we have 6, we can do minus 6. So if I have 1 plus 8, and then take away 6 looks like this, minus the 6. So we move it away from the horizontal bar. Take away 5, take away 6. And there we go. My final answer is 3. 7, okay, let's see. We have 5, and then add the 4, and then take away 7. Anybody have any questions? So what I did was minus 7. Minus 7 just looks like this. Take away 5, take away 6, take away 7. So when I add it, right, and I take away. Do the beads always... Yes, yes, Blue Panda. Yes, the top bead is always the number 5. Always has a value of 5. So it's actually the top bead. You're right. And so if I change to this, these are all 5s. So when we look, all of these beads are touching this horizontal bar. This is what's being counted. That's okay, Zorfi. So does that make sense, Blue Panda? So everything at the bottom always has a value of 1. So when we're counting, we do 5, 5, 6, 7, 8, 9. So if you notice, if this is all 4s, right, and then I want to add the 5, now we have 9. So if I look, if I have 1 and I add the 5, now I have 6. If I have 2 and I add the 5, now I have 7. If I have 3 and I add the 5, now I have 8. If I have 4 and I add the 5, and now I have 9. I use this one because it's nice and pretty. That's why. Okay, so we have the 6. So 7 and then 8. 8 doesn't have a lot of numbers either. So if I have 9, I'm going to take away the 8. When I take away the 8, it's 5, 6, 7, 8. So I take it away the 8 like that. So my final answer is 1. Oh yeah, no, thank you. Thank you for the question. I appreciate that. It's nice to know people are interested in learning the abacus. And so I do believe it's the greatest thing since sliced bread. Fuzz. And you call me Fuzz. It's my... Okay, Fuzz. Thank you. Okay. Okay. Okay, and 9. We add the 9, we take away the 9. That's it. Okay, so what have we done? What have we done? Well, what we've done was we learned how to move the beads. Because we learned how to move the beads, we can go to the next one. What is the next one? Well, the next one is how to add. Are we ready how to add, or are we ready adding and subtracting? We can do adding and subtracting, yeah? Another question, how do you do... Okay. So that's a very good question. Let me write it out. So the question is 10 plus 10, right? So when I look at my answer, when I look at my abacus, I'm going to put 10 on my abacus. So the first thing I'm going to do is I'm going to put 10. Look, if you see the number, it says 0, 1. So I just follow that. 0, 1. So I put the 1 here. Yeah? And then, what's my next number? My next number is, again, 10. So question, 0, 1. Is there enough beads to add the 1? Is there enough beads to add the 1? Can we add the 1? That's the question. Can we add the 1? Can we add the 1? Yes, we can. That's all we're doing. So what is my final answer? If we have this as a 0 and this is 2, this is a 2-digit question. This is a 2-digit answer. So what is my answer? Fuzz? What would be my answer? Nathalie? What do you think? 20. Exactly. It is 20, right? So what we just did is we wanted to make sure, thank you. Thank you. So what we want to do is we want to make it, let's see this one. We can do this too. We can do this too. So if you look, I have 002. 002, right? My next question is this, 02. So I put the 2 here. What is my final answer? What would be my final answer? Yes, it is. 200, 220. It is adding on the abacus. It is like adding. But the difference is we're seeing it on the beads. It's just like how we do, the blocks, right? So your question was 10, so I give you 10 columns, and I do another 10, so that's 10. So 10 plus 10 added together is 20. So the question is, it becomes more difficult when it's a bigger number. Then I would have to use, this, right? This is 100, so I have 2 of these is 200, right? That's 200. And then I add 2 of these, and that's 20. So when you add it all together, it is now 220. But on the abacus, we're using numbers. So when you show you 200, 002, I do that. And then I want to add 20, 02. Is there enough to add, is there enough to add the 2? Yes, we can add the 2. Okay, so I don't have blocks big enough for that. However, on the abacus, I do have, right? Because the question is 1, 0, 0, 0, 1, 0, 0, 0. So what does that mean? Well, we have our numbers. Remember our numbers, right? This is ones. Can you read that? That's ones. This is tens. This is hundreds. And this is thousands. Right? So when I look, 0, 0, 1, 0, I'm sorry, 0, 0, 0, 1, 0, 0, 0, 1. I add 1 here. Then I do it again. 0, 0, 0, and then 1. 0, 0, 0, and then add this 1. Is there enough beads to add the 1? Yes. So what am I going to do? I'm just going to move this bead up because it's 1. When we're looking at it like this, 1 and 1. It doesn't matter what all the zeros are when we break it down. Does that make sense, Fuzz? So when we're looking, we're just looking like this on the abacus. So we'd be like that. So I understand your questions, right? So if we added another one, let's say we did, okay, so my final answer is 2,000, right? So let's do 1,500 plus 1,300. When we look at it, my goodness. Hello, what's going on here? I should not have done that. Okay, there we go. So, when we're looking on the abacus, right, we do this first. So we have 1,500, right? On the abacus, that's what it looks like, right? I followed your account today because you're a good teacher. Oh, thank you so much, user. So, hold on, Nathalia. Hold on. So what are we going to do? We're going to add this number. We're going to add the 1, right? Do you see that? So we're going to add the 1, and then we go here. Can you add the 3? Can you add the 3? Yes, I'm going to add the 3. 1, 2, 3. So my final answer is 2,800. Okay, so my answer is 2,800. 2800. Okay, Nathalia, thank you for the question. It is 1, 2, 5, 3, 8. All right, we can do this question, but there's a foundation that you need to know, and we haven't done that yet. How do I know? because because the one thing we need to do is we need to understand how to make a 10. So before we do that, I can go straight into it and explain it to you. Don't be scared. Okay. So the first thing we're going to do is we're going to understand how to make this, right? So on the abacus, we do 1, 2, 5, 3, right? And then what are we going to do? We move it down and we have this number. Oh boy. We have that number. When we have this number, can I add the 3? See you later, Fuzz. So Nathalia, we are going to add the 3. Can we add the 3? Yes or no? Yes. Yes, thank you, user. Yes. So we're going to add the 3. Okay, now here's a tricky one. We're going to add the 8. Is there enough beats to add the 8? No. I only have 6 to add I only have 6. So what do? We have to do is this thing called making the 10. Do you remember how to make a 10 with an 8? So there's this abacus formula that we need to do, right? The first thing we need to do is understand how to make a 5, and then we know how to make a 10. But because we have the question now, I'm just going to answer the question. So the first thing we understand, usually I go through and I explain how we make a 5. But what we can do is we can learn how to make a 10. How do we make a 10? This is how we make a 10. Does this ring a bell? How do we make a 10? 8 plus 2 is equal to 10. Does that make sense? That this is very common, right? This is very common in abacus and in mainstream. We're teaching the kids how to make a 10, right? Not a problem. You add something, subtract something. Yes, exactly. So what we're going to do is we are going to...
You need modification! Modify!
What does that mean? The first thing we need to do in abacus world is we're going to isolate the variable. We need to add this 8. So to add the 8, we're going to utilize this combination. So when I add the 8, it will equal to adding the 10, right? But making a 10 is too much. So I need to subtract 2 to balance the equation, just as user 937 mentioned. Right? So what we're doing is and then after that, we're going to substitute this information for the 8. So when we substitute this information for the 8, we're going to add the 10, which means a 1 and a 0, 1 and a 0, and then we take away the 2. So what we just did is an exchange, a substitution. So, oh shoot. 1, 2, 5, 3, 3. Okay, so what we did here is we need to know is plus the 8 is equal to plus the 10 minus the 2. That's what we need to do. That is what we need to do. So when we look, we're going to plus the 10, take away the 2. We're going to add the 10, add 1, 0, 1, 0. We add the 1, and then we minus the 2, and we take away the 2. So my final answer is what? I'm going to see a book reading class next. What is my final answer, Nathalia? Nathalie. So when I look, it's 9. 1. Yes, exactly. Exactly. So what did I do? This right here is what we had to make a 10. Okay, so let's see how it looks in mainstream math. Yuko, I fully support this life. Thank you so much. I have a perfect, and was wondering what this abacus stuff is. Okay, so let's do this again in mainstream math. So if we have 2, 5, 3, 3, 8, right? What do we do here? We know that this is 11, and we carry the 1 like this. That's what we did, right? So what we did is this carry the 1, that's the 10. So we add 5, 6, 6, 7, 8, 9. Does that make sense? Yeah, and we carry the 1. This is the carrying of the 1. What we did here, this is the carry of the 1. We can do another one. Let's do another one. So here's my number, right? My question is 9. When I have 9, I have 9. And I want to add the 8. When I add the 8, I love this can be done in the abacus. Yes, right? And we don't need to count stupid pencils. So smart, smart, I love it. Oh, okay, good. So it makes sense, right? So what we're doing is we're substituting this information. We have this concept. And so when we add the 9, right, we know the partner of 8. The partner of 8 is 2. So they go hand in hand. They're like little partners. I remember the pencil. Yeah. I was so mad. But I was like, it was dumb. You know why? Because you can't scale it. You can't scale whatever the person was talking about. It was so dumb. Anyways, so here we're going to do is we're going to have the 8, right? The 8 is a partner of 2. So we're going to, if you notice, we have 10. This is directions. Yeah, right? Thousands of pencils. 97,000 apples plus 60,000 apples. Come on. Doesn't make any sense. Anyways, all right. it was. No, I'm just sorry. I can't call names. I'm giving you the result. The formula is giving you instructions. So the instructions is plus the 10, take away the 2. Plussing the 10 means what? Add the 10, add 1. That's all it is. 1, 0, 1, 0. And then take away the 2. Take away the 2. So my final answer is 18. Does that make sense, Nathalie? Yeah? Because what are we doing? We can do it again. Now we understand this concept. If you understand this concept, we can do it across down everything else. So we have it for 7. 7's partner is 3. It's the same thing. If I have 7, right? 7 plus the 10 minus the 3. We can do it again. And now we see the pattern. We see the pattern. How far are you going in math? We go all the way to division. You can do division and you can do decimals and you can do fractions. Yes, thank you. Thank you, user 397. Yes, 397. So when we're doing this, right, we want to add the 10, subtract the 3. So what we're doing is what? When we have the question is 9. Here's 9. 1, 2, 3, 5, 6, 7, 8, 9. 9. I have 9. I want to add the 7. When I add the 7, I'm going to substitute it. I substitute plus the 10 minus the 3. Just as user said, right? Plus the 10, 1, 0. Plus the 10, and then take away the 3. My final answer is 16. So what we're doing is we are no longer needing to do number lines, right? All the way to algebra 2. No, I don't do algebra. We do similar things. We do similar things like algebra, but we don't do algebra. I don't do algebra. I know if you're looking for somebody to do algebra, I know a girl. I know a woman. I know a math person. I know a math person that does algebra, and she does trigonometry and math 2, and I don't know what else she does, but she has higher math. I only do arithmetic. I only go up to arithmetic. Yeah. So what am I showing here? So now we see a pattern, right? We could do it again. We could do it again with a 4. Now this is when it gets a little bit tricky. Why? Because if you notice, we have this thing called minus 4. Minus 4 is very familiar, right? It's just the opposite. Okay, 6. Let's continue on with. So again, the question is 9. If I have 9, right? And I want to add the 6. What I do is I substitute it, plus the 10 minus the 4. So I go 9. I want to plus the 6. To plus the 6, I need to plus the 10. I'm going to plus the 10, and then I take away the 4. And I take away the 4. My final answer is 15. And that's it. I mean, again, we talk about, that's okay. Oh, I'll support this live. Oh, thank you so much, Modelo. Thank you so much. No, I appreciate you. Usually I just do basic arithmetic, adding, subtracting, multiplication, and division. Yeah. But if you're looking for something to do higher math, I know people. We talk. All right. So how are we doing? How is this? Anybody have any questions? So we can go on into doing the how to make a 5. The reason why is because that's also another critical thing. Why? Because how to make a 5 is also another pillar. What does that mean? Well, one thing is, oh, that's a 10. Make a 5. That's a 10. I have books. Oh, there it is. I have books. I have so many books. So, what are we doing? Okay, can you do that once more? How to do the negatives? It glitched me. We don't do negatives. We don't do negatives. We don't do negatives. But we do is minus. I don't. Is it a negative? It's very specific when you talk about negative. The answers are never negative, if that makes sense. If that makes sense, the answers are never negative. So here's the question, right? If I have the 4, right? If I have the 4, right? So I'm going to do is I have my making of the 5. Minus the 4 minus 1 equals to minus 5. So what's going to happen is I'm going to subtract. To subtract, it's the opposite. So when we look, we have 8, and then I want to minus the 4. Minus the 4 is minus the 5 plus the 1. When I minus the 5 plus the 1, and then my final answer is 4. So it's kind of like that, if that makes sense. So we can add, just as I said before, if we can add the 4, we can subtract the 4, right? So that's why this is another concept. It's exactly the same except it's a different operation. It's just a different operation. So if you look, minus 4 equals minus 5 plus 1. Here, it's plus the 4 is equal to plus the 5 minus 1. Yeah, not a problem. So and that's why this book, that's why I made this, the Abacus formula, because in here, it gives you a whole rundown of how to add the 5 and how to take away the 5. And so you could see the different combinations. And they look very similar. It just depends if you're adding the 4 or subtracting the 4. And usually I tell the kids just to do this, just to memorize this. Whereas I'm talking to adults, I would like to explain to them, why are we doing it? How are we doing it? What's the purpose as we do a substitution? But this is kind of helpful because it's also a dry erase. And so because we make a 5, we can make a 10. And that's what we did previously. We made a 7, we made the 8, and we made the 9. We made the 6. So we made the 6s. Then you can do takeaways. It's the same thing. We're going to take away the 10. We just take away the 1. And that's what we're doing, is we're just going through the questions to take away. Yeah? So when we're doing this, the question is 4. Okay, we've done that. How did we do it? When we add the 4, there's not enough beads to add the 4. What I'm going to do is I'm going to utilize this 5. I'm going to plus the 5 and then take away the 1. That's a little confusing. Well, it's okay, because let's say we have cats in a tree. So here I have 4, right? I have 4, and I need another 4, but I don't have enough. So I need to go to the cats in the tree. I grab 4 cats, right? I go to the tree, to the 5 cats in the tree. I grab 4 cats, but then 1 cat runs away. So then 1 cat runs away, and my final answer is 8. We can do it again. Sometimes it works better with a little money. So if I have 4 pennies, 4 1 cents, 1, 2, 3, 4, right? We have 4. And then what do we need? The 4. We're going to add another 4. But to add another 4, I only have 5 cents. I only have 5 cents. So I'm going to give you my 5 cents. I'm going to give you my 5 cents, but that's too much. I need change back. So I take away the 1. So I give you my 5 cents. It's too much. Give me some change back, and my final answer is 8. Did that make sense? I know I glitched somewhere around there. How did that look for you? Is that all right? Okay, good. Nathalia, are you still around? Nathalie. I don't know if Nathalie's still around. Anybody else have any questions? We can continue on. We can do it again because we have 3. When we have 3, and I want to add the 4, right? I have 4. I want to add 4, but because I add 4, I don't have enough, right? Cats are really, oh good. Yeah, I try to make the story, I should do it more often in the live, but I don't do it in the live, but I should, because I forget. I just think that people know. So, what we're going to do is we're going to do 3. When we do 3, I have 3 pennies. 3 1 cents. I gotta change for 4, but I have enough, right? I have 5 cents, but this is too much. So if I give you 5 cents, I need to exchange it out, right? So then my final answer is 7. So I go give you my 5 cents, and I take away the 1 cent. My answer is 7. Okay, how are we doing? Yes, so that would be cool because we did the 4, but notice when I add the 4, right, it's plus the 5 minus the 1. When I subtract the 4, yes, you're getting it. When I subtract the 4, it's minus the 5 plus the 1. And so so what I was trying to do here is I was trying to make people write. We can do 3. And then it's the same thing with 2, and it's the same thing with 1. Yes. Okay, so it's the same thing. So if I have 3, I don't have enough, so, and I have to add another 3. I don't have enough beads to add the 3, so what do? I have to go to the cats in the tree. They take out my hand, my cat's in the tree. I grab 3 cats, go to the cats in the tree, I grab 3 cats. But then 2 cats run away. When 2 cats run away, right, yes, add the 5, take away the 2. My final answer is 6. Exactly. I like the cats in the tree because it's easy to see on your hand. And so if you have it on your hand, you can, if you don't know, you what you're trying to do is you're trying to grab 3. So if you grab 3, you know that it's 2. So it's the same thing with here. If I have 4, right, and I grab 3, right, I go to the 5 cats, I grab 3, 2 needs to go away. So my final answer is 7. Okay. Okay. So that's the plus. We can do the minus. We can do the minus because I don't do minus very often, and I think we need to do a little bit more minus. So here is the question, right? I'm not sure if we were here for that, but this is 16. So if I have 16 and I take away the 4, we know minus the 4 is equal to minus the 5 plus the 1. Now we're doing the opposite, right? Minus the 5 plus the 1. And it magically appears to be the answer, which is 12. Kind of cool. Right? And so when we do it, we could do another one. We do, I don't know, 15. When we do 15, we do 15. Oh, I should write 15 here. I'll write it, 15. So 15, right? Minus 4. I have 15. And take away the 4. To take away the 4, what do? Minus the 4 is equal to minus the 5 plus the 1. So what I'm going to do, minus the 4, that's what this is, right? I'm going to minus the 5 plus the 1. Minus the 5, add the 1. My final answer is 11. Yep, exactly. Thank you. Thank you. No, I appreciate, yes. Makes sense, right? Because sometimes it helps to see it. Sometimes it helps to type it out. And so that was the thing. When we start doing it, so then this is like, trying to figure out the different ways that it happens. And so there's 4 petals, there's 1 petal missing, so which way does the way abacus goes? If you notice, they go up, right? They go up. So when I look at my abacus, right, this is 8, and what we're going to do is we're going to take this, and we move it up like that. That's what we're doing. That's how you add the 5. Add minus the 4, we go up. When we add the 4, we go down. When we take away the 4, we go up. The big focus is the 5. The 5 is the one that the 5 is the one that directs what does the direction, if that makes sense. Real question. Oh, practical question. I don't know. What's your practical question? All right. So we have 7. When we have 7 on the abacus. And then when we do minus the 3, this one I did pots. I did flowers in a pot. Is abacus practical for everyday use? If you do adding, some subtracting, and multiplication and division in every day, then yeah, you could. Is it practical in real life? It depends on how old you are. I mean, do I do it? I do it every day, all day, because I teach abacus. You know what I mean? How much doom scrolling do you do that teaches you math, and are you intrigued? Well, you know what I mean? Like, it's usually geared towards kids. And here's a question is, do you do jigsaw puzzles, right? Or do you do Sudoku? Or do you do word searches, crossword puzzles? It's in the, low key, I found another 7-column abacus for $6. Great. Fantastic. I think it's a good way for the kids to learn. It was more familiar to visualizing ours. Yeah. 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 It's usually geared towards kids, but since I've been on TikTok, since I've been on here live and stuff, I find a lot of adults are very interested. Either they're adults and they have children, or they're adults and they have nieces and nephews that they want to teach, or they're adults and they just find it fascinating because it's like a puzzle. So is it practical in real life? It just depends on how much math you do in your life. You know what I mean? So that's more of a subjective question. If the kids get excited by it, they'll practice more and be better at math. Yeah, that's true. It's just like if they like the piano, they're going to practice more. If they like, kind of the same, right? So usually in America, abacus is looked at as an enrichment program, but I'm trying to show it as it's more fundamental. It's more fundamental. And I feel like we introduce all these math manipulatives, but we don't introduce the abacus as a manipulative, which is sad. But I guess that's why I'm here, to show to...
This is the way.
This is the way. This is the way.
Does that make sense, Kayla? So, excuse me. Math is used in everyday math. Some may use calculator. Yeah, exactly. I mean, if you go grocery shopping, you do math all the time. I always look for bargains, right? I try to see which one is the better, bang for my buck, right? Do I use a calculator? I could. Or I can do it in my head. Or I get my kids to do it. It'd be good if you could do it yourself or with an abacus. Yeah, you can bring it to the grocery store, right? Or even to the restaurant if you want to, and you can calculate how big your bill will be, right? If you have a large party and you want to, and you could do it in your head if you practice enough. Or so it's like as many times as you use a calculator, you could use an abacus. Or you could be good with an yeah, visualize in your head. Yeah, exactly. But I do feel that the abacus is, it's easier to see, like the host just said. Yeah. So yeah, I don't know if Kayla's still here, but it is what it is. Oh, okay. So we're back to here. So we have 3, and then we have 7. Okay. So we can do it again, right? We have 36. We're going to do 36. We have 30, and we have 6. And we want to do is we want to take away the 3. When we take away the 3, do we have enough? No, we don't have enough. Hey, Kryptonics. What the sigma? Oh my goodness. So what we're going to do is we're going to minus the 3. We know how to take away the 3. To take away the 3, we can utilize this 5. So it's minus the 5 and then plus the 2. So then when I open it up, my final answer is 33. No, it's not your internet. It's TikTok, Kryptonics. TikTok is lagging because it's lagging for everybody. They've been having troubles for a few days now. All right. So does that make sense, user 397? Yeah, we're okay. So we did the minus. We could do a -2, right? It's the same thing, but here is my pattern. Notice when I started going through and I looked at my questions are very specific. So this blue here or green, whatever color this is to you, this is what we call simple. That means is there enough beads? Yes. So if I have 4, I'm going to add 4. Can I add the 5? Yes, I can add the 5. So I'm going to bring it down. So my final answer is 9. So when we look, these are simple. This is my second day watching it. I'm already getting it. Yeah. Yeah, this is fantastic. So here is pink, right? This is pink. When we see the pink, this is where we do the +5. And then we have the yellow. All of this yellow that you see here is adding the 10, which is fantastic. We have subtraction, right? We have the adding. This is simple. This is -5. Here is -10. And then here is what we call the two-step equation. We've done a little bit of the two-step equation, just as we did here. So we could do the adding of the two-step equation, or we could do the minus of the two-step equation. Which one do you want to do, adding or minusing? It doesn't matter. It's all the same concept. It just depends on how you Tetris your way through, right? So what we're doing is we're understanding how everything works. And then it goes into fantastic, like, bigger numbers. And it's the same process. So it's the same pattern, and it's really quite interesting. And as we go through, like we do 16, this is the, you want to do the minus? Okay. So this is the 2-step, and then we have the 10s, and then this is the 5, and it goes through over and over again. And this is the pattern. And it's interesting because in Abacus, we nobody's ever done that, but nobody's ever done the same pattern in mainstream math either. So we're going to do minus. When we minus, let's do this. So we have 10, right, -5. When we have 10 minus 5, that was easy, right? We know what 10 minus 5 is. Because we have 10, take away the 5. Again, we're going to look at our handy dandy chart, and we want to minus the 5. Minus the 5 is minus the 10 plus the 5. And that's easy, right? Minus the 10. So we have 10. And then we need to minus the 10 plus the 5. Okay, that's not a good one. Let's do another one. Let's do, okay, sorry, here, 13. So, oh, that was another question. I don't know if you were here for that. So one question is I had no, that was the addition. So let's do 13, take away 8. We know this one. How do we know it? Because we have 1 and the 3, right? 1, 3. We have 13. Now we need to do is we need to minus the 8. To minus the 8, what do? We know minus the 8 is equal to minus the 10 plus the 2. We know this. We've talked about it. Minus the 8 is equal to minus the 10 plus the 2. 10 minus 1 minus 0. Minus 1 minus 0. Minus 1 minus 0. We're done with the 10, right? And then don't forget we have to add the 2. When we add the 2, look, there's not enough. This is where we have our framework. So the question is can we add the 2? Is there enough to add the 2? No, there isn't. I only have one bead to add the 2. So the next one is, can we add the 5? Can we add plus the 2 is equal to plus the 5 minus the 3? Can we add plus the 5 minus the 3? Yes, we can. Plus the 5 minus the 3. My final answer is 5. That's what we call a two-step. So what did we just do? We took this and we had to substitute plus the 5 minus the 3 into here. So my final answer is 5. Did that make sense? We can do another one. Let's do another one. All right. 14. We'll do 14 minus 7. These are very simple, but understand when you know the fundamental, right? Then you can scale it. So again, we're going to do not memorizing our doubles, because there's no such thing as double negative. There's no doubles in a negative format, because it'll all just be 0. So we have 14. We have 14. We're going to minus the 7. We know how to minus the 7. Do you remember what the formula is to minus the 7? Right? Minus the 7 is what? Minus the 7 is minus the 10 plus the 3. Minus the 10 minus 7 is equal to minus the 10 plus 3. Thank you, user. Yep. Easy, right? Because we know that these are pairs. So we're going to minus the 10. When we minus the 10, we need to add the 3. When we add the 3, what are we going to do? There's not enough beads to add the 3. So we know we don't have any more beads to add the 3. We got to go back to our framework. To add the 3, minus the 3, add the 3, because we're taking away the 7. So what are we going to do? We're going to add the 5. Can we add the 5? Can we add the 5? Yeah, we can add the 5. So what do? We need to plus the 5 minus the 2. That's what we're doing. So we're going to plus the 5 minus the 2. So my final answer is 7. 5, 6, 7. Yep. Right? So my final answer is 7. Yeah? Make sense? So that's what we call a two-step. The reason why is because this becomes substituted with that. That's why it's called a two-step. Yeah. In Abacus world, they call it mixed formula. But I don't call it that way. Why? Because it goes bigger than just here. Here's another question. It was 54 minus 9. So we have 54. We want to take away the 9. We cannot take away the 9. How do we take away the 9? We know minus the 9 is what? Minus the 9. What do we know? We know minus the 9 is equal to minus the 10 plus the 1. Minus the 9 is equal to minus the 10 plus the 1. It's a two-step we were talking about yesterday. Yes, exactly. This is what we call a two-step. But this gets more. It gets more complicated. But yeah, we're going to get here, right? We have minus the 9. We're going to minus the 9. We need to minus the 10 plus the 1. Minus the 10. We have to take away the 1 here. How do we take away the 1? So here, we need to minus the 1. Can we take away the 1? Oh, wait. Can we take away... No, sorry. Hold on. Hold, please. Okay. Can we take away the 1? No, we cannot take away the 1. Can we use the 5? Minus the 5 is equal to plus the 4. Can we do that? Yes. Minus the 5 plus the 4. Minus the 5 plus the 4. We are done with this one, right? We did that. Now we got to do this one. We got to add the 1. Is there enough beads to add the 1? No. There is not enough beads to add the 1. What are we going to do? We don't have enough. We need to add 1. There's not enough. What do? Can we add the 5? Can we add the 5? Yes. Plus the 5 minus the 4. Plus the 5 minus the 4. So what did we just do? This one became plus 1 is equal to plus the 5 minus 4. So this is what I call three-step, right? But see, the thing is I don't call it mixed formula. Abacus world, they call it mixed formula. But I'm calling it two-step, three-step equations. This one is now 3 steps because we did 1, right? 2, 3. And it kind of follows a little bit like algebra. So now this is a 3-step. But then it gets redundant. It doesn't matter because why? We know how to add and subtract the 5. We just know how to add and subtract 5. Or we know how to add and subtract the 10. See, this is how they're very critical to how they go into each other. Does that make sense? So, and that's what becomes more versatile. Oh, what's my answer? 50, 40, 45. Excuse me, 45. Yeah. Yeah, I like this question because it shows the versatility of understanding your formulas. Yeah. There's more. I mean, don't get me wrong, there's more. It's just one of those things to just kind of go through and understanding. There's, it's a lot about practice too. Okay. We could do more. We could do more minus, or we could do adding and subtracting. So it's up to you. I mean, I think it's just you and me. Anybody else can chime in, but if you don't understand, let me know. We can do a review. If not, we're going to continue on to adding and subtracting. Yeah, I think, which abacus are best for beginner, kindergarten to expert? Well, I like this one, but this is limiting because you only have 7 columns. So some of the kids like this one when they're young, and then they graduate to this one. And I think 13 is enough for the numbers because you can choose any indicator to be your ones. So I think this one is more versatile. The 13 column one I think is more versatile if you only want to buy one abacus. If you want to buy 2, I would recommend doing the graduation from colored to single color. I just think it's more fun, but I mean, my boys, they had the 13 column. They had the 13 column one or the 23 column one because that's all we had. I think 23 column abacus is a little bit overkill because I haven't seen any numbers bigger than that. And even when we do division, we don't need to do all of those numbers. That's a really big abacus. This is my old abacus that I have. This is 23 columns. And it's made out of bamboo, and this has been with me for about 20 plus years. What about the ones I've seen with the 5? If you can find it and it's cheap or whatever, or you like it, you could use it, but it's different from what I'm teaching. So my books are very specific to the soroban. You can use this one, the Chinese one, because that's what you're mentioning, the 2 beads on top and the 5 beads on the bottom. This is Chinese. You could use this one with my workbooks if you want to, not a problem. You could just use the ones in the middle. If you want to do the full extent, we can do that. So when we talk about it, I don't have worksheets to go with the Chinese abacus. They all go with the Japanese abacus. But to understand this one, it's 1, 2, 3, 4, 5. And then what we do is we trade. So this is 5. We're going to bring this to down. This is 5. And then we do 6, 7, 8, 9, 10. And then we're going to trade it again and make this 10. But then we got to trade it again and make this 10. So there's a lot more trading in the Chinese one than there is in the you still need to know your formulas. It works just the same, but there's more trading. So this is 5, this is 10. So I got to trade this in to make it 10. And then I got to trade this in to make this 10. So now we have 10. And then we could do 11, 12, 13, 14, 15. And then we could do 16. 16. 16. Right? Why? Because I trade this in for this number. So it'd be 16, 17, 18, 19, 20. So now we have 20, and we would have to do that. 20. We could do that too. So there's a lot of trading in the Chinese abacus, but you still need to, when I was researching a little bit more, you still need to do formulas. So it was interesting that you can do your 5 times table and your 6 times table without any formulas, but when you get to 7 and 8, 9, then you're going to have to use the formulas. I haven't tried 2. So 2, 4, 4. See, you can't do it for 4 because you need to use a formula for this. Plus when you want to add the 2, plus the 2 is plus the 5 minus the 3, then we get 6. Yeah. You still need to use the formulas. It just depends on what the numbers are. So then it'd be 6, 8, right? 5, 6, 7, 8, and then 10, which is fine. So then you trade this in for 5, and then you trade that in. Okay, so then you have 2, 12, 14. Oh, so right here you have to do the formula. 16. There's another one. What? 3? See, now I'm just workshopping it. 3. To add another 3, I need to use the formula plus the 5 minus the 2. You get 6. Add 3, and then what? You need to add another 3. To add another 3, 1, 2, 3, 4, 5. No, 5, 6, 7, 8, 9. To add another 3, what do I do? Plus the 10 minus the 6? No. Minus the 7. You still need to do formulas. Is there different formulas in the abacus? No. No, the formulas are all the same. It just depends on when you use it. Just as I did here. So we did 9, right? 9 plus 3. You don't have enough beads to add the 5. Plus 3. Plus 3 is plus the 10 minus the 7. So the formulas are all the same. The Chinese abacus is still the same. It just depends on when you use it. It just depends on if you need it. 6 times 3, right? 18. 1, and then 5, 6, 7, 8. And then 6 times 3, 4 is 24. So we trade this in, we make it 20. And then now we have 24. 6 times 5 is 30. 10, 20, 30. We trade this in to make it 30. And then 6 times 6 is 36. 6 times 7 is 42. You would have to think about it, though. I mean, I'm still a little tripped up when we see it. But you got to think about it. It is up to you. If you have the Chinese abacus and you want to use it the Soroban way, all you would have to do is just utilize the middle. You could do that too. It's up to you. I mean, to each their own. But the formulas are still the same. All right. Are you a mathematician? No. What made you like math and want to teach it? I actually didn't I did like math. But what started is my dad went to Korea. I'm Chinese, and he went on a business trip to Korea. And he went to, and this mom of some sort was like, I think abacus is the greatest thing next to sliced bread. And you need to teach this in America. And my dad was at the point where he wanted to open up his own business. And so he does what every Chinese man does, or Asian parent does, is he forced us, my brother and I, to learn abacus, because I was like, I don't even know what an abacus was. I never grew up with an abacus, but this was 20 years ago. And so he made us, because he wanted to open up a learning center for his retirement, whatever. So I learned how to use the abacus, and I saw that this was the greatest thing next to sliced bread. And I taught all I made my kids learn abacus as well. But as a young parent, you don't have a lot of time. Now my kids are a little bit older. I'm really creative with my workbooks, and so I'm trying to be more intentional to try to make this abacus more mainstream. So I don't know if that made sense. So my brother, he actually still owns the learning center. My dad retired, and my brother took the brick and mortar. He has a school out in Monterey Park, and I decided to try to make this into online. So I have online classes. I have videos to go through all my worksheets and to go through all of this, and then I have the TikTok lives, and I'm thinking about doing a boot camp for adults, that wants to learn more and instead of repeating. Yeah, I'm in Monterey Park, and so we've been teaching abacus for 20 plus years, and so learning how to relate abacus to mainstream math has been one of the first things I started to do when trying to get this to be online, because I do feel like that it would be cool if we can introduce this to mainstream math. But I think for right now, I mean, people know about Singapore math, but they don't know about abacus, which is really interesting, because abacus math has been around a lot longer than Singapore math. Yeah, that's cool. I remember abacus in elementary, but we didn't get to use it. No, yeah, you didn't use it because the teachers were never taught. And so I think that was the one thing I wanted to do, is if I get more teachers involved to try to introduce abacus to their students so they don't have to worry too much. Because you'll notice that even on the abacus, it's really intuitive that there's all these place values. You know what I mean? So there's all these placements that they don't have to worry about it because the abacus does it for. We had oh yeah, yeah, yeah. The big 10 beans. Yeah, yeah, yeah. I've seen those too. Um, those, I think that's called the Russian ones. Excuse me. And then we have the blocks. Excuse me. And then we have the counting bears, and we have all this stuff. We have all of these other manipulatives, but we don't have. But I think the difference is, in abacus, the questions are very specific, right? I've told, if you notice again, right, the questions are very specific, and you do one block at a time, right? You can do one number if you want to, but I go by blocks. That's why you see the way it's broken up. I have +5, -5, +10, and so forth. Someone gave me some of those blocks. What are they for? They're for counting. They're for understanding. They're for understanding quantity. So here's the blocks, right? We have our ones. These are our ones. And then these are 10. And then you would trade it in. And then this is hundreds, right? I don't teach public school, so I don't know specifically how they use it. But from my understanding, right? From my understanding, I got a box with those in different colors and sizes. Oh, if you notice, if you get one and you have a number that's 2, you'll notice, I don't know if you have the one where they have numbers, you'll see that they're equal distance, right? And then if you have 3, they're equal distance. So then you know if you add the 1 plus 2, you get 3. So it's great for small numbers, but it doesn't scale, right? It doesn't scale like the abacus. So then the problem is like, we have our numbers, we're adding it all together. But when we add it together, we got to break this apart, and we got to start grouping them into tens. Right? We got to group this into 10. So this is 10, right? So we got to trade this in, and we got to take this away. And then we got to count this. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So this is 28, right? That's what would happen. So if I have all of the, you know what I mean? So it's more, my teacher friend who's in 2nd grade doesn't like the blocks, because when you have 30 kids using these blocks, it gets a little bit difficult management wise. So practicing the smaller number, yeah, this is for practicing for smaller numbers. They try to add like this for the big number. This is like the hundreds, and then this one is the thousands, which is a cube. It's just to show them what 1,000 looks like. But you know the interesting thing? The mind doesn't see anything more than 5. So this is too big for me. It doesn't make sense to me. I don't know when. I will never see anything that's 1,000 in, I don't know, anything 1,000. I don't even know, like, yeah, this is 1,000 because it's 100 times 100 and then times another 100. So yeah, it's 1,000. So this is 1,000. This is 100. So there's 10 of these. 1, 2, and then you, like, you know what I mean. And then there's 10. There's 10 blocks. So that's what they're for. Yeah. It's to show quantity. But that's about it. And they do it with trading in and stuff. But man, it gets a little cumbersome. You could do it, you could do it. They do it with multiplication too, right? So that's 2 times 2 times 2 times 2 times 2. I mean, that's easy, but do I teach high school, college level? What, abacus? Thanks. I know. And no hate have the battle. Yeah. Yeah, I haven't heard that in a long time. I was so, I'm sorry, cool 5. No, I teach arithmetic. That's all I teach. Adding, subtracting, multiplication, division. That is all I'm doing. And I do it with the abacus. My biggest thing is using with the abacus. You know, I'm a huge G.I. Joe fan. G.I. Joe is a code name for a highly trained special mission force. Its purpose is to defend human freedom against Cobra, a ruthless terrorist organization determined to rule the world. That's why we connect so well. I love that. Anyways. Why? I quote that all the time. This is cool. Is there an anime where... Yeah, there is an anime where a girl protects the... Well, I don't know. But yeah. So we can go further into multiplication if that's alright. How are we doing on time? Okay, I think doing one more question on the... Let's do minus. Oh no, we'll do another adding. You want to do adding or subtracting? We could do either. I don't know if you were here for this one. This one was a good one. Were you here for this one? 12, 1, were you here for that one? 1, 2, 5, 3? Yeah? Okay. Yeah. So that's what I'm saying. It's like, it's scalable. There's another one. Where's the other one? Yeah, I think the biggest my thing is just getting the curating the numbers. Abacus. I'm sorry. Why? Why abacus? Why not? This is the fun grade. Oh, what am I doing? Oh, I do the minus. I gotta do minus. Okay, let's do some more minus. Yeah, that's the 2-step. And it's interesting about the 2-step. But that's the thing. In abacus world, they call it mixed formula. And I'm like, that's so generic. But really, what it is going through everything you know, how to add the 5 and how to make a 10. If you know how to make a 5 and make a 10, everything just fits very well. Like Legos. Hatch. Abacus. Do you think the colorful abaci would help visually better in your head? No, I don't think it matters if the color is in your head. You know what? It depends if you see color in your head. And that's a thing. So some people actually can see numbers in colors. So it depends. It all depends on like how your brain works, which is really fascinating. I see color in my head. So you might, if it helps you, then it'd be good. I don't know. Honestly, I don't know if this color representation makes sense to you. You know what I mean? Because when I do 6, when I do 1 and I want to add the 6, it's 1 bead on top and 1 bead on the bottom. But this 6 is a moving bead because this is 5. So if I have 2, I do 6, 5, 6, and I do these 2 beads. So now we're at orange and blue. So if I had 3 and I want to add the 6, It's now blue and red. You know what I mean? So I don't know if these colors will help you. It might be better that if you see the colors in your brain, you might want to use a single colored one and then you can see the numbers on your own. Yeah, I can completely philosophize about this because it was so fascinating. Maybe I should be a mathematician, but it just fascinates me in how the different ways we do things. So it might be easier for you and not get confused with the colors that are here, if that makes sense. Oh, sorry, hatch. Why an abacus? It's to help adding, subtracting, multiplication, division. And we can do multiplication, division later on. So I know sometimes people, on my lives, people are like, well, sometimes the colors are overwhelming. And that it makes sense, right? So that's why there is this version. Sometimes, I use this because it's just prettier. Majority of the people are, whatever. Majority of the people enjoy the colors. Sometimes it's overwhelming. Sometimes, there's this one person, saying, well, I'm colorblind. And I'm like, that's not a problem. You can use this one. You cannot tell me that you're colorblind and not do abacus. I thought it was hilarious. And then she, whoever it was, they laughed too. Because it's no longer a problem. Like once the answer is on an abacus, I can read it faster with a color. Okay. So then it's it's whatever is easiest for you. It all just depends. I like this abacus. But I think if I have more, it would be overwhelming. There is a 13 column abacus that's this color, like this. There's others that are just all white. There's different styles, right? All white. They have like blocks. This is one color, one color, one color, one color. Yeah. Oh, I don't know if Hatch is still around. Why abacus? Count to help count. Hoodlum gaming. Yeah. Anybody have any questions? Oh yeah, you're ready to buy some abacus and start practicing. Oh, that's great. Yeah, it's interesting. Like if you enjoy puzzles, I really enjoy puzzles. So I really gravitated to seeing like math. But now what my thing is my higher goal is not to do puzzles, but to be able to introduce this to students because I really do feel that it works very well with just being able to visualize and being tactile, which is really fascinating to me. Like I could bring in my boys, but honestly, they're gonna take it for granted because they're still young, right? They don't understand the benefits of having this in their brain, and I don't push them to, do this in their head. I do push them that if they have a problem, to do it on the abacus if they need to, but they're getting older now and they can use a calculator, but when you can't, right? You're Thank you. Enthusiasm is infectious. I appreciate that. And that's the hope. The hope is it goes into mainstream math. But I do have some naysayers, obviously, right? Because they'll be like, that's too complicated. But we also come from school where we had to memorize and we were not told, oh, that was the other thing. That's the interesting thing about the abacus is that it actually nurtures critical thinking. So when you're starting to look at your numbers, you have to critically think if you have enough. If you have enough, if you don't have enough, how do you do it? And that's the other thing. Like it starts that critical thinking that doesn't happen with kids now in mainstream math. And so that was the other thing is like, and analyzing and substituting and isolating and all this stuff. These are all the beginning parts, and also focusing on the add-in and not the result. Whereas it switches in the middle of like I think 5th grade, they start doing the add-ins. They start doing that. You're not just taught memorizing with yeah, exactly. It's not memorizing without understanding. And this is where it starts to get really like, oh, okay. And that's the other thing, like, we talk about critical thinking, but this is also changing of the thing, right? So in mainstream math is interesting because we're always telling the kids, how do you make an 8? I'm like, why are we learning how to make an 8? So some of the things, like we need to know fact families of how to make an 8. So we know 1 plus 7 is equal to 8. And then 2 plus 6 is equal to 8. And I'm like, why do we even need to know this? Why are we teaching them this? What's the point of this? There's no point. 3 plus 5 is equal to 8. There is no point for this. You know what I mean? But it makes sense to make a 10, right? 8 plus 2 is 10. But we focus on this in the earlier ages. And then when we go into like algebra, then they start talking about the in-between stuff. Hello, Dylan. You know what I mean? Now we start talking about what is this thing? And it's like, what's the point of teaching them this if we got to go to this? There's no logic on that. It doesn't make sense. And I don't know why we started teaching them this if we need to understand that. Does that make sense? Because this is algebra, but we need to know how to make stuff. I've been on for about an hour and 45. And I'm actually wrapping up right now. I'm just ranting. You just caught my rant. Yeah. Okay. Oh, good, TV girl. Oh, my. Okay. Let's do one division. Let's do one multiplication question for TV girl. And let's see how this works for us. I don't know if it's a good number or a bad number, but I will take it slow. Let me know. Let me know if you get confused anywhere on the steps. So the first thing we're going to do is it makes more sense to learn the 10s and the 5s. I don't know why I just don't know. Okay. Focus. Okay. So the first thing we're going to do is we're going to do some multiplication. Now in Abacus, what we need to do is we need to memorize our multiplication facts, right? And then what we need to also understand is we're going to do distributive property. That's what we're doing. What are we doing? Why are we doing that? The reason why is because it is new math. No, it's not. New math is actually Abacus math, which is interesting. And so the first thing we're going to do is we're going to understand where are we going to put our answer. 1, 2, 3, 4. 1, 2, 3, 4. Why am I here? Because I'm using this as my ones indicator. Remember, this is my ones, and I'm just going to count from here. 1, 2, 3, 4. When I do that, right, now this is where it gets distributive property. What that means is I'm going to do 2 times 5. I have 2 times 5 is equal to 10. I add 1, I add 0, right? New math, what does new math do? New math does 20 times 50 is equal to 1,000. But if you look, I already have it on my abacus. 1,000. 1000. Right? So am I doing 1000? Am I right? 20 to 50. Yeah. 10. Oh yeah, because 5 times 2 is equal to 10. Right? So this is what new math is. This is abacus math. I'm not sure about you guys, but this is what I read my multiplication table. I don't know multiplication table that goes up to 20 and 50. But I know why they're doing it, because they have to write it on paper. Abacus keeps it for you. 1000, right? Now we're going to do is 8 times 2. 8 times 2, 2 times 8 is 16. Add 1, add 6. In here, we're going to do 20 times 8 is equal to 160. So if you look, I do 160. 160. But again, I don't. This is what you were doing yesterday. It was glitching. So this is 0, right? I don't need to worry about this. I just need to worry about this. So all I did was added 1 and 6. 1 and 6. We're done with the 2. Now what are we going to do? We're going to go back and we're going to look at our numbers. 1, 2, 3. 1, 2, 3. So now what are we going to do? We need to do, again, distributive property. 5 times 5. 5 times 5 is equal to 25. So when we do this, we're going to add 2. Can we add 2? Yes. Yes, we can. We're going to add our 2. This is where it gets a little sticky. We know how to add a 5. Can we add the 5 here? No, we can't. What do we do? To add the 5, we know plus the 5 is equal to plus the 10 minus the 5. We're going to plus the 10 minus the 5. So what we just did is plus 5 is equal to plus the 10 minus the 5. Okay? Now, what's left? Our final is 8 times 5. 8 times 5 is equal to 40. Can I add 4? Can I add 4? I can't add 4. How do I add 4? Plus the 4 is equal to plus the 5 minus the 1. Right? Good. Plus the 5 minus 1. Plus the 5 minus 1. So my final answer is, what's my final answer? 1,410. That's the answer. Yeah, not a problem, TV girl. Yeah, that was a good question. It was a good question because it wasn't too complicated with the numbers, right? Because then we did this one too. And so we broke it out. But again, if you look, this is how to make a 5. This is how you make a 5. This is how you make a 10. And so if you know both of them, everything is golden. It's just how it all touches its way through. Doesn't blue down mean 5? Yes, it does. Oh, yeah, thank you. Thank you. Thank you so much. It is 50. Yes, 1450. Yes, you're right. This is when I know I'm tired, when I start making mistakes. So that's my last question. Thank you, King. Thank you so much. I appreciate that. Thank you. All right. All right. Yeah, if when I start making mistakes, like reading mistakes like this, I know it's time. So, but again, this is multiplication. So with our multiplication, I mean, obviously, after multiplication, we could do division, but that takes a little bit of understanding. It's very procedural based. But the first thing we're going to do is make sure that we understand how to add, subtract, and then we can go into multiplying. And then after multiplying, we can do division. And then what's after that? Then there's, that's cool. I never knew how an abacus is used from the, oh, did you want to do a review? But no, you got the 5. You got the 5. So we have 1, 4, 5, and 0. So you know how to read the abacus. That's really cool, though. From the one problem. That's pretty cool. Yeah. A lot of people jump straight into multiplication, but there's a lot more adding and subtracting fundamentals that needs to happen before they go into multiplication, because you're just taking multiplication and you're doing fast adding. So, all right. Thank you everybody for joining. Yeah, the numbers are starting to pick up now, but it's okay. I'm gonna end the live. It's been a little bit. I do appreciate everybody joining and having a comment. Yeah. Great live. Oh, thank you so much. I appreciate you. And there was not too many trolls. Dylan, please. We don't need to know what you're doing on the toilet. Yeah. Oh, yeah, not a problem. Thank you. I appreciate you, joining and and I changed your mind. It's always great when, when people just are, open their eyes to something different.
Welcome to the real world.
Hey, E, I was just about to sign off. Thank you so much, King, for the donut. Thank you so much. Yeah, I'm about to sign off. I apologize. Yeah, we did a little bit, and then just going through some adding and subtracting, and we did some multiplication. Thank you, TV. TV girl. Thank you, TV girl. All right. I am signing off. Thank you guys for joining. Thank you guys for the comments and the gifts. Thank you so much for the gifts. I do appreciate that. I will see you guys all in my next live. I think tomorrow will be earlier. Have a good night. Have a good night. Thank you again for joining. And I'll see you guys tomorrow morning. I'm going to try to be here at 7 a.m. Pacific Standard Time. That's the goal. We'll see. 7 a.m. Pacific Standard Time. Tomorrow morning. All right. Good night, everybody. Thank you, and good night. Who did that? Johnny Cash, I think. Carson. Johnny Carson, I think it is. Okay. Bye, everybody.